In that bus are 3 teams being driven to one of the most beautiful locations the Great Egg Race has ever used. One of the 3 will go forward to our semi-finals competition. But first, they must win this one. Welcome, gentlemen, to an excessive amount of fresh air. I wonder if you'd like to disembark. Come along here. I wonder if you'd just like to follow me when you're all out of the bus. Right, just follow me along here. Let the wind blow through your hair. I can't do that very much. Well, teams, we've brought you to the Giant's Causeway coast in Northern Ireland. I suppose you'd like to know what's in store for you. Well, in the next bay, a ship of the Spanish Armada sank with a lot of treasure. More recently, some BBC pirates have got some of this treasure and they've hidden it in this bay. What we'd like you to do is to make a map of this bay. Now, in order to help you, there'll be 4 fixed points, some of which may not be accessible, and you certainly can't measure distance between these, which will allow you to establish a coordinate system. At the end of the game, we'll give you the coordinates where the treasure is buried, and we then ask you to find it. But we will assess marks on the basis of finding the treasure and producing the best map. So start mapping.
I'd love to know how we're going to mark this out.
Don't worry about that.
The northern lights see themselves as shining like the aurora borealis, which Les Gorman can sometimes see from his Orkney croft. He says lateral thinking and rubbish dump reclamation are everyday facts of life for him. Alex Barr is a lecturer in architecture, and Mark Tyler, a BBC radio engineer, who says he can make booze from anything.
That's it. So
they're also keen Morris dancers.
Yeah.
So I can leave you play with that lot. I'm going to walk up on the cliffs over the top there.
Yeah, okay.
Go round. Okay. So I'll see you.
Let's make it big and bold.
I'll see you in an hour's time.
Okay.
Okay.
Bye.
By then we'll have it all made, Les.
If this is sweeping around here, we're going to need some information about where them climbers are now. Around here.
The Stranmillis College team consists of Cyril King, lecturer in craft design and technology, who organizes and judges science and technology fairs around Europe. David Neal and Gareth Clark hope to graduate this summer as craft design and technology teachers. And Gareth's competitive urge has already brought him one of the Irish Young Scientist of the Year titles.
Should be
dressed there tonight.
Right.
Thanks, it's a pencil.
Yeah, so it's a bit longer one.
I want to walk off and get some screws.
And finally, the red team. Richard Dovison is engineering manager of a GPO sorting office, which he also designed and built in the first place. Paul Sysum is an engineer and builds sets, props and special effects for local amateur dramatics. Tony Whiting is an electrician and opening batsman in his village cricket team.
That's there. We can make a small slide on it so we can see the angles.
Whilst the teams are surveying their options, let me introduce my guest judge, who is Michael Brand, Director of the Ordnance Survey of Northern Ireland, and therefore a very senior mapmaker indeed. Now, Michael, you must admit that it's a difficult problem, and that having given them a child's geometry set isn't perhaps the best which we could have done for them. But how difficult is it really?
Well, you've made one of the comments that is a very large area that we have with this amphitheatre here to survey. We have problems that much of it you cannot get to. You can't measure between various points here. And of course, you can see the size of the cliffs around us. They're nearly 100 meters or more in height, and that will pose further problems.
But you have been merciful, haven't you, in that you have been given a little bit of help.
Yes, we've given them some control points to start with, some reference points. The first one is out there at Seagull Island. As a stack, the very point of that stack is the control point, and you can see by looking at the seagulls where it got its name from. And of course, on top of the cliff, also to help, at the end of one of the fence posts up there, just by those people that are walking past at the moment. The third point is at the top here of the steps, which are the end of the shepherd's path, right by the fence posts that you can see at the top.
Yeah.
And the fourth point, of course, is at the corner of the building, just where we are.
Which incidentally, being a public convenience, is now known as a judge's convenience. But in your infinite mercy, in fact, you've done another thing for them, haven't you?
Yes, well, what we've done is actually plotted for them a grid, or provided a grid, and the coordinate values of each of the reference points.
Which you've just described, the four you just described there.
They will be able to plot on this as the framework for the survey that they'll have to build up.
Well, let's see then, to what extent the teams are in possession of the simple elementary knowledge, or whether they'll have to invent it as they go along.
That's the direct maximum angle we're going to look on inclination.
50?
50?
Yeah, I don't think it'd be any more.
No.
Probably
Badly more
nearer
than adequate,
30,
I
so
think.
it's...
So if we got that on there. Right,
Well,
that's
you've
it.
had about an hour now, and I think the first hour is probably the worst, because you're trying to make up your mind what you're going to do.
Yeah.
It looks as if you have made up your mind.
Yeah.
Tell me what it is.
Well, first of all, we've got to establish exactly where we are here within the bay.
Yes.
And from the four coordinates you've given us, which is the island, Gulls Island out to the left there.
It's a little bump on top of the
It's
bottom.
that bump out to there just in the sea, yes. The post on the top of the cliff right at the far end.
You have to have good eyesight to see that.
Certainly, yes. Good job the mist is not in. The shepherd's path where it goes up through the cliff, the coordinate there, and the building just adjacent to us.
So you've got those 4
We've
points.
been given those 4 points.
But you don't know where you
We
are.
don't know where we are in relation to those as such.
So what steps are you going to take to establish where you are?
We're going to use...
Oh, you've got all yourself a map on the blackboard.
Map,
Could you
yeah.
just bring the blackboard over here?
Right. If this is the outline of the bay,
Yes.
we've got the building here, we've got the point at Gulls Island down here, the other point on the cliff top there.
Yes.
We're somewhere in this area. So we're going to take, using an angular instrument we've made, we're going to take a line out to the Gulls Island,
A bearing, yes.
your bearing, and just fix that at a 0 bearing for now.
Yes.
Then going to swing the instrument round and take a bearing across to the building there.
So in fact you're
Give
measuring
us
this
an
angle.
Give us an angle in there. And from that position, we should then be able to work our way back with that
where we
angle to a unique point.
Well,
that point.
so it's this distance that you're also going to measure.
You're going to measure that distance, yes. That's the only one we can really measure. None of the other distances are...
Well, that's with balance of force to some extent.
Yeah.
So there are 2 measuring instruments you've made yourself. Let's have a
Yes.
look at those.
yes,
The first one is the distance measuring one.
yes.
Well, that's the sort of thing you find people wheeling along the roads.
Along the road, yes. And what we're going to use this for, we've worked out what the circumference of the wheel, the bicycle wheel,
Yes.
is. And we just go from the starting point to the building, count the number of revolutions of the bicycle wheel and multiply it up to give us a distance.
Right, well, that's fair enough. The more difficult one is how to measure the angle, the bearings
Yes.
between these 2 points, or just several points.
There we need 2 instruments. One is this. We just plotted out a circular, mark the degrees on it. What we're going to do is set this up in a fixed position and leave it there, and then we will sight the various landmarks we've been given on these nails, which will give us a direct reading of degrees. That will move round. We will sight just for line of sight.
Second round, yes. And the rest of the detail we'll have to add in as we locate the edge of the cliff.
Well, Cyril, how are things going?
Not too bad, thanks. We've just checked the accuracy of the instrument by lining from this reference path at the top here, across to the toilets and across to the stack, and we have verified that that is 60 degrees according to the diagram. Well, we felt that if we could get the edge of the cliff reasonably well marked in and get an idea of the shape of it, particularly which way it runs, then from up here we can get a much better impression of what's happening down below.
Okay, just put it down.
Gareth and David, that's an ingenious, simple theodolite for measuring horizontal and vertical angles that you've made.
Well, it was just made out of simple pieces of wood, and we just measured out the angles for it, and then from then we tried to get angles reasonably accurate, because it's not the angles which are important, it's the difference between the angles which is far more important for simple trigonometry purposes.
One of the problems we've given you, of course, we're given a known height down there above sea level, is to actually give us a height of this reference point here.
Right.
How are you going to go about doing that?
Well, I think we intended to use this sliding block here, which is marked out in degrees, giving us the vertical height. And the other side, we're using reference points.
Well, it'd be interesting to see, what sort of result you'll get at the end of it.
Thank you.
Here comes the rain again. Oh, sorry. Sorry, Mum.
Where's your third man?
He's wandering around doing us a rough sketch and working out where we're going to take our points.
97, 98, 99.
Now, if I wasn't such a seriously minded chap, I would have said that you were making a coffee table. But tell me what it really is.
It's a device for reading sightings in two planes.
So you've got a scale along here to be read against this pointer.
That's right, yes, in 360 degrees.
Yes.
And we've got a vertical scale,
Along
90
there.
degrees. And by looking along these sights, we can take a bearing from one of 2 points up at the top onto an object down at the bottom.
Right, but you can look either way. I mean, if it's something which is, you're looking uphill, as it were, your eye could be here.
That's right,
And if you're looking downhill, for instance, from the top of the cliff, your eye could be here.
Yes, that's right.
You better draw this for me on the picture, quite how this works out, and how this relates to the fixed points which we've given you.
Okay, well, if we've got cliffs like
Schematic
that,
will do.
yeah, and here's the sea, and here's the rocks at the bottom.
Yes.
And by putting those devices, one up there.
This one of the fixed points we've given you.
Yeah, this is one of the fixed points,
Yes.
so we know where it is on the map,
Yes.
on the coordinate system. And another one here, looking down there. Then by having somebody down here,
So this is your third man, perhaps.
that's right, somebody down with, say, a flag, then we
Yes.
can take a bearing down from
Yes.
one of them and
Yes.
take a bearing down from the other. But also that these are in two planes, so we know.
Because you aren't working on the flat, you're working from the
That's
top
right.
of the cliffs. Yes.
So if we had a map of the bay like that, and then we'd have a bearing in that direction and a bearing in that direction.
Yes. That's perhaps the more important one. And you can get your third man to walk about.
Yes.
And so you can map all the points on the bay which he stands at.
That's
He's a
right.
moving mark on which you take aim.
That's right. Yes. Yeah.
Right. Thanks.
Yeah. We hope. Okay. How are we doing?
You did very well there, Alex. Even I understood it suddenly. I mean,
Oh, good.
The angle is
right.
354 degrees, 12 minutes. 354 degrees, 12 minutes. And the distance 721. 721.
Here we've got Henry and Joe, who are professionals at this job, and they're working for the Northern Ireland Ordnance Survey. Now what they're doing is to plot the exact route of that pass over there, but they're doing it the easy way, the contemporary, the state-of-the-art way, by using an electronic distance measuring equipment, or a total station as it's now called. Now let's have a look at the instrument itself. There are really two parts of it. this part of it here, combined with this platform, this best platform here, and this set of pivots, is really an ordinary theodolite, but it measures the angles electronically and displays them on these dials here. And it's really exceedingly sensitive. Now, what makes the instrument really special is this portion here, which allows one to measure distance directly. Now, the way it does it, that at a distance point, there's a reflector like this, which is held by an assistant. And what this instrument does is that it measures the time of flight of light emitted from here, going to the distance reflector and coming back again. And because the speed of light is very accurately known, the distance can be computed by electronic circuit inside this instrument. Now, the way it's being used here is that the readings which are being read off these dials are plotted on this plotting table here, and here we can see the beginning of the path taking shape. But when this instrument is used for real, these electronic readings can actually be recorded as this plotting stage is emitted. The readings are then played back at the office and can be converted directly by an electronic plotter into a map. Now, that's a lot easier than the task which we've given to our teams. But on the other hand, this piece of equipment costs at least £25,000.
Can you take a bearing out onto that rock, onto the Gull Island?
Okay.
Saw that. Okay.
All right. Well,
So you've got a bearing?
85, the left-hand extremity of Gull Island.
To Gull Island. So we draw across from Gull Island to where we are. Okay.
Okay.
Right, if we swing...
Right-hand side.
Yeah. Right.
74.
74, right. So if we draw a line now from where we are,
Right.
down
To there.
What, the
down
end
to,
of the...
down to where we're going.
The end of the rock as well.
End of the rock
I'll
formation.
go to the onto the end of the rock.
Day 2 is dawned. The teams have worked into small hours plotting their readings and are now putting the finishing touches to their maps.
Right. I think his one is going to be lower. I really do, because if you take the parallax and looking out to sea, right, he's got here, what's he got? He's got 50. He's got 62.5 plus 16.
Yeah.
63 plus 16.
Well, 63 plus 16.
79. Just call it
79, 80. Yeah. Okay.
So he's got 80. Well, if you look at it outside, it's logical because it's going to be lower. Because if his looks lower from here, it's got to be quite a lot lower.
I thought he was on a level, exactly on the level, 0 degrees. But I mean, this.
If you look from out there, Mark.
If you what are we deciding for the heights? Mine's
80, 114.
No, it's the other way around.
Sorry, you're...
Now it's time to see what the real thing looks like. First, from the air. We've got an aerial photograph of this bay, but I understand, Michael, that even that has certain distortions in it.
Yes, and as a result, we're not able to use it to make a direct comparison.
So what we have done is to prepare a transparent version of the Ordnance Survey map to the same scale. The map produced by the blue team is already in place, and Mike is now going to superimpose the Ordnance Survey map on it. See how it corresponds.
Well, straight away we can start making a comparison. We have, in fact, the height points here in red. You can see now the shape of this island, Seagull Island, being somewhat different,
Very different
from its actuality. But the general shape is good. Part of the cliff, as we can see as we come along here, is starting to move away from its true position. We have a little problem with the scale of the size of the hut, remembering that 1 millimetre on this map is 2.5 metres.
On the ground.
On the ground. And of course, when we get round to the Giant's Causeway here, the difference between where this team has portrayed it and where the actual causeway itself is displaced quite a lot.
Now for the marking system. Mike and I have agreed that he'll award a mark between 0 and 60 for the quality of the map and for the kind of instrumentation which was used by the map makers. There'll be another mark between 30 and 5, 30 for the team which goes closest to the treasure, or even finds the treasure, 15 for the team which gets second closest, and 5 for those who are third closest or furthest away, as the case may be. And then another 10 marks, a maximum of 10 marks, entirely in the judge's gift for the prettiness of the map. Now, Michael, bearing these criteria in mind, how much would you award for general map-making skill for this one?
For the skill, and one can only really judge it by the end product, there are quite a number of departures here, and I would say 28. 28 for the blue team. And for prettiness, if you just look at it now... Well, from the presentation, it's clear and...
It's really very good, isn't it?
It is, and would be very easy to find your way around on this. I think 8.
Next, we look at the map produced by the red team. Michael, first some sort of general standard.
Well, it's different anyway. And, you know, the cartographic clarity that we had on the other one isn't there. But let's look at the accuracy of it, because that is also very important. And right from the beginning, you can see that the general shape of the whole cliff top, and more importantly, the path, follows very well along the line. They guess somewhat the shape of the island up there, but the footpaths, the seats, the huts aren't that far away.
The huts almost is exactly coincidence.
Yes, the giant chair is where it ought to be, and the general shape of the causeway has seemed to have come out very well.
Well, how about your mark?
Marks, I think, for accuracy anyway, I would say 45.
And how about the more
the presentation leaves a lot to be desired, and I think 2.
And finally, the yellow team. Michael, how do you assess it for cartographic quality, I think is the word you used?
Well, this is very much neater and very clear. And they have included quite a lot of additional information about the vegetation and so on. So I quite like this.
Well, let's
have a look at the accuracy of it. We have, in fact, quite a lot of, again, a little bit of a disparity between the top of the cliff here and where they themselves thought that it ought to go. I mean, we've got maybe 150, 200 meters difference along the top of that cliff. But the area along the bottom is, in fact, very much better. The organ is where the...
organ actually is, yes.
And also, of course, the edge of the causeway there is very close to its true position. Yeah. I would say round about 40 points for the marks on this one.
40 points for the map itself, and how about the
I would say we ought to, I think, maybe 7 here.
Right. Well, so we are really very close. The whole competition could still be decided on who gets the treasure first or who gets closest to the treasure. We're now going to tell the teams where the treasure really is. Mike has written the coordinates on these pieces of paper. I'll give 1 to each team. For you, 1 for you, 1 for you. Now go and dig it up. Now in the meantime, Michael, show us on your real map where it's buried.
We have buried it just...
Right. All we have to do now is wait. Good heavens, they're off already.
So you get your warm Max.
And moreover, all setting off in the same direction. That is, except for the blue team, who are invisible at the moment. Perhaps considering the matter.
Yeah. 33.
The yellow team seem to know where they're going.
No, I meant don't twist your foot. Oh, that will slow you down.
Where's the bench?
Or do they?
No, right, now wait a minute. Turn it around that way. Oh yes.
Now the people running around in all directions, really casting about like a pack of dogs. This is really rather like a race with 3 different finishing posts. But still, there's a fair amount of purposeful activity.
What distance is that, Gareth? 200.
And it's now converging into an area which means they're really getting quite warm.
Here, isn't it?
Sightings off things. Edge of the WC goes.
Breton?
How about the?
Well, this has got the bearings right.
The stack.
Got the bearing right.
Stack's actually line between the trig point and the stack.
Going which way?
This way.
North to Island. Yeah.
25 metres that way.
85 from the base.
That way from that line.
Well, that's the line.
Bring a shovel!
Never is it?
I don't know.
No, Alex. The trig point's the left-hand end of that. Is it? Yeah.
It's got to be.
It's
Off the web!
85, 86.
86, that's good.
This
That is the point. We're here somewhere.
Here.
Come on.
Can't believe they buried it in
I think
here.
we've got it up for here
So
somewhere,
here?
Tone.
Where is the
Take
right
it.
place?
Go on, take it here.
You found some freshly dug earth, have you?
What?
Dig.
Dig,
Make
Tone,
it
dig, Tone.
That one. Are you happy with it?
Well, where's the map?
Come on, lads. Pick me a rotten place.
Go on.
Right. Okay. Round here somewhere.
There.
What's that, Tone? What's that, Tone? What's that? That's off. You can get the pebbles out the way.
Pebbles out the way.
Got it? Got it? Bring it up.
That's it. This is it.
That's it. That's it.
Crack
Look
it,
at the
mate.
bottom.
The bottom.
There we are.
What have we got in here then?
Whoa. Hey up.
They've got the treasure.
Look out, yeah? Is that worth a lot of money?
Well, those are the treasures from the Girona, the ship that of the Spanish Armada, which sank over 300 years ago just off this coast. And I can see there that you have the cross of the Knights of Malta, and I think in your other hand there, the famous salamander set with rubies.
Well, we can now announce the final marks. The red team scored an additional 30 because they found the treasure and scored a total of 77 marks. The blue team got second nearest to the treasure, scored an additional 15 marks and now attain a total of 51. And finally, the yellow team scored an additional 5 marks for being least near to the treasure, but it did rather well on the map, and they score a total of 52. I therefore would like to congratulate the red team from Gloucester Postal Engineering as being the winners of this week's egg race. Now I must thank Michael Brandt for being such a marvelous judge and for being so deeply involved with the provision of this program. And also thank the Northern Ireland Ordnance Survey, the Ulster Museum, who provided the replicas for the treasure and where the real thing can be examined. Last of all, please find your way again to this program next week. Goodbye.